Hello, we are the Gravity Driven Car Group. So let's start by introducing our members first. Our members are Namvan, Him, Pika, and Momo. For this project, we're focusing on using gravity as the main source of energy to move a car without using any motors, batteries, or fuel. The main question that our group is trying to solve is how can we design and build a car that moves efficiently and smoothly using only gravity as its power source? This project aims to help us understand how gravitational potential energy can be transformed into kinetic energy through our pulley system. It also explores how forces such as motion and friction affect the car's movement in a real-life experiment. Our group chose the gravity-powered car because we wanted to learn how gravity can be used to create motion without using motors and fuel, and to better understand physics through a hands-on experiment. By solving this problem, students will benefit by gaining a better understanding of energy, motion, and friction. It can also inspire ideas for energy-efficient designs in the future.
Our hypothesis was that if a falling mass is connected to a pulley system attached to the wheel, then gravitational force will cause the car to move forward. The material that we use are: one is cardboard, second is wooden stick, third is wheels, fourth is pulley, fifth is screw, sixth is glue gun, seven is string, eight is tape, nine is heavy object. The procedure: first, build a car base and attach the wheel. Second, install a vertical support pole. Third, attach the pulley to support pole. Fourth, put the rope through the pulley and connect it to the wheel. Fifth is add a heavy object to the end of the rope. Sixth, take the car by releasing the weight. Seven, adjust the design to improve movement and reduce friction. Observation: when a heavy object was released, it moved downward due to the gravitational force as the mass fell. The string was pulled through the pulley, causing the wheel of the car to rotate. The car began to move forward in a straight line. At the beginning, the car moved slowly, then its speed slightly increased as the mass continued to fall. Some friction was observed between the wheel and the ground, which affected the smoothness of the motion. After adjusting the alignment of the wheel and tightening at the string, the movement became more stable and consistent. Result: the results showed that the car was able to move forward using gravitational force alone. The car mass successfully converted gravitational potential energy to kinetic energy, which was transferred through the pulley system to the wheel. During the experiment, the car traveled a distance of 70 cm in 4 seconds. This demonstrates that gravitational force can be effectively converted into mechanical motion using a pulley and a wheel system.
Project initialization, planning, role, and responsibilities. At the beginning of the project, our team discussed different ideas such as how amusement park rides use gravity to move, or how a basketball moves when it is thrown and fall back down. So from these ideas, we decided to build a gravity-driven car. And next, we planned how the project would be carried out. We designed the structure of the car, list all the materials needed, and discussed how the pulley and axle system would convert gravitational force into motion. And we also divided the role and responsibilities among our team members too. In this project, we divided the work among the group members. Him was responsible for preparing and organizing the materials. Momo was the main person who assembling the components of the car, while Pigger helped fix the components. And I was responsible for improving the design and editing the videos. Proof of work. After we bring the materials, we start assembling the components, and after that we paint the car and test it. During testing, Momo tries to wrap the string tightly around the axle that connects the wheels. Next, we thread the string through the pulley attached to the vertical support pole, and after that, I securely tie the other end of the string to a heavy object. When we lift and release the weight, gravity pulls the object downward. As the weight falls, it pulls the string through the pulley. This causes the car move forward. After that, we measure the distance and start timing how long it will take. Next is the troubleshooting. At first, the car didn't move at all when the object was pulled down by the gravity, so our group tried to figure it out what went wrong. We thought that the object might be too light, so we add weight, but it still didn't work. So I brought the car back to the dorm, fixed it, and tested it again. The first issue I noticed was that the cardboard base was too heavy, which made it difficult for gravity to pull the car forward. And to solve this problem, I cut the cardboard to make the car lighter. However, even after reducing the weight, the car still didn't move properly. So next I tried adjusting the axle between the wheels. I made the axle thicker by wrapping it with a rubber tube and adding several layers of tape. This was done to make the axle stronger, prevent bending, and help the wheel rotate together more smoothly. However, the car still didn't work as expected. And after observing more closely, I noticed that when the car started to move, the wheels and the axle were not rotating together. This caused the wheels to slip and lost energy, which preventing the car from moving forward efficiently. To fix this problem, I used a hot glue gun to secure the connection between the wheel nuts and the metal rod connecting the wheels. After strengthening this connection, the wheels rotated together smoothly, and as a result, the car was finally able to move forward when the object was released. And next is energy calculation. Things that we know are mass of the hanging weight, which is 2.5 kilograms, mass of the car 5 kilograms, total mass of the system will be 7.5 kilograms. Height of the hanging weight is 50 centimeters or 0.5 meters. The distance traveled by the car is 70 centimeters or 0.7 meters. Time taken is 4 seconds. And the acceleration due to gravity is 9.8 meter per second squared. So first we're going to find the gravitational potential energy, and it is calculated using only the mass of the hanging weight because it is the object that moves downward due to the gravity. So the formula that we're going to use is mgh. M is 2.5, G is 9.8, and H is 0.5. So the answer is 12.25 joules. Secondly, we're going to find the velocity of the car by using the formula velocity is equal to distance over time. And the distance is 0.7 meters and time is 4 seconds. So the velocity is 0.175 meter per second. Thirdly, we're going to find the kinetic energy, and it is calculated by using the total mass of the system because both the car and the hanging weight move together, and the formula is 1/2 times mass times velocity squared. So the kinetic energy is 1/2 times 7.5 times 0.175 squared, and the answer is about 0.115 joules. Finally is the energy loss. So for this step, we're going to subtract the potential energy by the kinetic energy. So we use 12.25 minus 0.115, and the answer is approximately 12.14 joules. In conclusion, this shows how gravitational potential energy is converted into kinetic energy, but not all of the energy is transferred efficiently. Discussion and conclusion.
Alright, so now I'll be explaining what went well, what issues we faced, how we overcame these issues, and what we can do differently in the future. Now, first, what went well? I personally feel like the first few days of the project went swimmingly. We finished the boards, and then each and every single day, we all had our assigned roles. where we each did our jobs and we did it on time. So I feel like the cooperation and overall workflow was great between the entire group, and we barely had any days where we weren't really working. Now, what didn't go so well was the last few days. So one of our core members, him, had to miss a few days of class due to her attending the C game, which is alright. I understand, which is alright. So it was a bit harder to divide the workload in those days due to missing a group member. And we overcame this problem by working with each other. And through working with each other, we managed to divide the workload, which was gained from missing a member of our group. And eventually we were able to completely assemble the board and then begin testing. So what can we do better in the future? So in the future, I personally feel that we should pre-plan the project better, because we think that the pole for the board could be higher to produce more force. And we feel like we could also do more on the planning part. Although the workflow was good, we think that with even more planning, we could have finished this project even earlier and had more time to mess around, experiment, and change variables. Now, this project had us use many of our SOs, but I want to highlight 3 main ones. First of all, it required us to think innovatively. We had to think of how to accomplish this project from scratch, as there was no active guides which could accurately guide us through this project to align with the guidelines. This also required us to be strategic learners, to find obscure information and utilize those informations to assist us in making this project possible. This was also due to time constraints, as we had to use time effectively to complete this project. Now, finally, we had to be articulate communicators. We had to articulately convey the information that we found onto this card piece.